Good day, everyone. Hi, I am Teacher Jor. So for today, we are going to tackle about Calculus 1, Limits and Continuity, specifically in our Lesson 2. So our Lesson 2 is composed of the limit theorems, evaluating the theorems of algebraic functions and our transcendental functions. But for this video, we are going to focus on our limit theorems, specifically in the constant rule, identity rule, sum and difference rule. So for the other theorems, we will tackle it for our next video. So let us begin. So, let us begin with our limit theorems. So, in this lesson, we will learn how to compute the limit of a function using the limit theorems. So, limit is a mathematical notion based on the concept of proximity that is used to give values to specific functions at locations where no values are defined in a way that is compatible with our neighboring values. So, limit theorems or limit laws are useful principles and qualities that may be used to determine the limit of a function. So guys or class, we have to take note that throughout the entire discussion, we will assume that the two expressions, the limit of f of x as x approaches a and the limit of g of x as x approaches a exist, and our a is a constant number. So let us start with the theorem number 1, constant rule. So this limit law states that the limit of a constant c as x approaches a is just equal to the constant itself. So if our function looks like this, the limit of c as x approaches a is just equal to c, where c is a constant number. So this theorem basically means that the limit of a constant is always a constant. So I'll give you an example. So example number 1, we have the limit of 5 as x approaches 4. So in this case, our c or the constant number is equal to 5. And according to our theorem, if our function looks like this, then the limit of a constant number is always a constant. Therefore, the limit of 5 as x approaches 4 is equal to 5. Now for example number 2, the limit of negative 2 as x approaches 0. So in this case, our c is equal to negative 2, while our x is approaches 0. And in this case, if we talk about constant theorem, we don't have to look at where our x is approaching. We just have to look at the value of our c. And the limit of negative 2 as x approaches 0 is equal to negative 2. And this is according to our constant rule. So that is our constant rule. Now for our second theorem, we have the identity rule. So the law of limit states that the limit of y equals x as it approaches a is equal to the number or a as x approaches it. So here comes the difference of our constant rule and identity rule. Because if we talk about our constant rule, we just have to look at the value of our c or our constant number. Hence, the value of x doesn't matter. But for our identity rule, we have to look at where our x is approaching or the value of our a. And our function is just always x. So if our function looks like this, where the function is just x and our x is approaching any number for that matter, then that will be our answer. That will be the limit of our function. So for more application, here is our example number 1. So the limit of x as x approaches 2. So in this function, we have x as our f of x or our function, and our x, the value of our x is equal to 4. Therefore, by using the identity rule, the limit of x as x approaches 4 is equal to 4. Yes, we just have to look at where our x is approaching, and in this case, it is equal to 4. Hence, that is our limit. So, example number 2, the limit of x as x approaches 1/3. So, according to our theorem, then the limit of example number 2 is equal to 1/3 because our x is approaching 1/3. So if our x is approaching a, hence our y or the y value also approaches a, or where our x is approaching the value of our a. So the limit of x as x approaches 1/3 is equal to 1/3. So that is our identity rule. So it is very obvious what is the difference of our constant and identity rule, because if we talk about constant rule, we just have to look at the value of our c, while in the identity rule, we have to look at the value of our x. Okay, so let us proceed to the constant multiple rule, or our theorem number 3. So the constant k can be factored outside of a limit. So we have to remember that suppose we have the limit of f of x as x approaches a, where it is equal to L. Then the limit of k times the limit of f of x as x approaches a is equal to k times L, or the value of our k multiplied to the limit of our function, where k is a constant number. So if our function looks like this, if we have a constant number next to a function, then we have to apply constant multiple rule. Okay, so let me give you an example. So the limit of 5x as x approaches 3. So we have to evaluate its limit. So in this given function, we have 5 as our k, that is the value of our k, and x as our f of x, or our function, while our x is approaching 3. So first, we have to separately treat the limit of our k, or the constant number, outside of our function. So we have to put 5 outside of our limit, so it will become like this. So 5 and the limit of x as x approaches 3. So it is very clear that we can't get the limit of our function directly. We have to put 5, our constant number, the k, outside of our limit in order to simplify the function. So our function, the limit of x as x approaches 3, now we can proceed to applying the what rule? Of course, it is the identity rule. So by using identity rule, the limit of x as x approaches 3 is just equal to 3, because we have to look at the value of our x. So it will become 5 times 3, and 5 times 3 is equal to 15. Therefore, by using the constant multiple rule and incorporating the identity rule, we have the limit of 5x as x approaches 3 is just equal to 15. So that is how we use the constant multiple rule. We have to remember it because the constant and the identity rule together with the constant multiple rule, it is one of the most basic theorems because it is used mostly or almost all the time, okay? So next, we have theorem number 4, the sum or difference rule. So the sum rule reiterates that when we take the limit of the sum of two functions, the result is equivalent to the sum of the respective limits of the function as x approaches a. While the difference rule is similar to its addition counterpart, it also states that the limit of two functions' difference is just equal to the difference between the limits of each function as x approaches a. So, for example, we have a situation where we have two functions as a given, where it is the f of x and g of x. Suppose we have the limit of f of x as x approaches a, which is equal to L, and the limit of g of x as x approaches a equal to m. Then we can proceed to getting the limit of f(x) plus or minus, it depends on what operation is on the given problem, the limit of g of x as x approaches a, which is just equal to the limit of our f of x or the L plus m. So, if we are given the situation where we have two functions and it is separated by an addition or subtraction as its operation, then we have to proceed using the sum or difference rule. So, we have to remember that, okay? So, for more example or for more application, I have here one example. The limit of 2x plus 4 as x approaches 1. So it is very obvious that we have to use the sum rule because our given function has addition as its operation. And then first we have to separate getting the limit of our two functions, our f of x and then the g of x, and then proceed to adding the two functions or the limit of our two functions. So it will become the limit of 2x plus the limit of 2x as x approaches 1 plus the limit of 4 as x approaches 1. So we have now separated the two functions. So let us look at our first term or our first function. We can proceed to simplifying it. So we have to break it down by using the constant multiple rule. So it will become 2 and the limit of x as x approaches 1 as is our second term, the limit of 4 as x approaches 1. So now we can proceed to simplifying and then getting our limit. So the limit of x as x approaches 1 by using the identity rule, it is just equal to 1 and multiply it to our k, which is 2. So 2 times 1 plus our second term, we have to use the constant rule. So 2 times 1 plus 4. So 2 times 1, that is 2 plus 4, and that is just equal to 6. So the limit of 2x plus 4 as x approaches 1 is equal to 6. And we get this limit by using the sum rule. So that is how we incorporate our sum rule. So have you noticed that we have used the constant multiple, the constant, and the identity rule? So as I have said earlier, it is one of the most used theorems or limit theorems. Okay, so we have to remember that. So that is all. So that is the example of our limit theorem, the constant rule, identity rule, constant multiple rule, and also the sum or difference rule. So I hope you have learned something, class. That is our lesson for today. So we will continue tackling our limit theorems on our next video. So that is all, and this is Teacher George. So bye! See you again, class!